1.3, reliability measures. So in this part, we like to, talk about a little more details. We want to define some concepts related to the reliability measures. So when we start, we look at this concept called Service Level Agreements, SLA. So this special type of agreements usually are used in, the current popular service case, cloud computing. So many companies right now, so they like to use cloud computing services. So in that situation, there are providers, consumers, right? So in this picture, you can see the service provider. Let us just assume the cloud computing service provider. Then consumer, the customers, the companies, they need to use those services. Then some agreement must be signed between the two parties. And here we just focus on one specific type of services, dependable services, because the customers are very serious about if the service provided dependable or not. Yes. So for that reason, they really want to get some very strong agreement from the provider. The infrastructure providers start offering SLAs to guarantee. How can you guarantee, right? To guarantee that their networking or power service would be dependable. But the guarantee should be reflected in some numbers, right? Otherwise, you just use some vague terms. Then when something is wrong, how to make the two sides settle on the problem, right? So here, then in the agreement, there should be something like this. They would pay the customer a penalty. Yes. Some penalty, if they did not meet the agreement more than some hours per month. Yes. So some numbers here using hours per month. Here. Because when you set the service interruption time should be certain number of hours per month, right? Because to be reasonable, it is very hard to promise there is no interruption in the service. So that's not realistic. So the customers, they accept some reasonable number of hours per month. So for example, let's say 1 hour per month. How about that? So in each month, only 1 hour interruption time is allowed. So that's an average. So that could be average or maximum, minimum, based on the agreements, right? The agreements should write that clearly. If the real number is more than that, then they should pay some penalty, to give the customers some compensation. Things like this. So let's look at the two states of service. One from the positive direction. It's called a service accomplishment. So that is, the service is delivered as specified in the agreed SLAs. Yeah. So that's from the positive direction. But another should be from the negative direction, right? Called a service interruption. Yeah. So where the delivered service is different from SLA. Yeah. Different, that part, what you should do, the penalty, right? Yeah. All the details should be specified. Yeah. All right. So that's the, the background, yeah, of this. Yeah. And here you can see the service provider. So those companies, infrastructure providers, those companies, so they should do their best to make the service interruption, the impact, as little as possible, right? The impact. Yeah. So you want to make your customers happy. Yeah. So if it's possible, you need to, send alert or, do some preparation to help your customers reduce the loss due to the service interruption. Yeah. So that is very important. Yeah. Only in that case, then the customers will be happy, so they will keep using your service. Yeah. Otherwise, they will change to a different provider. Okay. All right, so next, we want to look at the measures. We call it module reliability measures. Here we use the general term module. Yeah. So every part, every component, we do not need to specify the, detail hardware part. We just say one module, one general module. So module reliability measures. First, we want to describe the module reliability. So what do you mean the module reliability? Yeah. So it is a measure of the continuous service accomplishment. Yeah. Continuous service accomplishment. So when you talk about continuous service accomplished, you should have some starting point and end point, right? Between 2 points. In between, continuous. Okay. Continuous period of time. No interruption. Okay. All right. And the starting point, some reference initial instance. Yeah. Initial instance, the reference. Yeah. Because when you measure continuous accomplish that period of time, every time you do the measure, that period could be different, right? Sometimes longer, sometimes shorter. Yeah. But how do you measure that in that situation? Yeah. Yeah, it's easy. Yeah. People commonly use the average. Yeah. Average period of time. So that's the concept, the measure we call it mean time to failure, MTTF. Mean, that's the average, right? Yeah. So you do statistics, measure many different period of times, then you take average. Yeah. So mean time to failure. Yeah. All right, so you start, measure, start working, then you clock it. You look at the time. Yeah. Then when the first failure occur, after certain period of time, sooner or later, one failure would occur, then you calculate that period of time and write down. Yeah. So mean time. Yeah. You do this kind of thing many times, plenty of times, then you calculate the mean time. So mean time to failure. Yeah. That concept. Yeah. Next one, called the failures in time. FIT. Failures in time. So we want to look at the, the reliability issue, but in different way. So we look at it in this way. Number of failures in time period, in certain time period. Yeah. All right. So this one actually is the reciprocal of MTTF. Yeah. For example, so here, I just use a simple example. Yeah. Let's say mean time to failure equals 1 million hours, for example. Yeah. So that's a big number, 1 million hours, for example. Okay. Yeah. Then this FIT take a reciprocal, 1 over 1 million. 1 millionth. 1 millionth. Yeah. Then we understand in this way. In 1 hour, in each hour, how many failures do you expect? 1 millionth failures you can expect in 1 hour. Yeah. That's the FIT. Okay. All right. But usually people use a different unit. Yeah. So in failures per billion hours of operations, in failures per billion hours of operations. Why that? Why is that? Yeah. Think about if we use the same example, 1 million MTTF. Yeah, 1 million. We take reciprocal, then you will get a very small number, right? So 1 millionth, that is a very small number, 0.00, many position after the decimal point, too small. Then this kind of measure will not be very good from the human psychology to people. Why? Because when people see that small number, 0.00, many 1, people will get the impression this is a small number, we can ignore it. So small, then we don't care, we just ignore it. Yeah. Then it's not good, yeah, because you don't want people ignore that number, right? So the idea is do some conversion, change the unit to make that number look larger. Yeah. So we actually the same number, but we change the time unit, period unit. Yeah. So we make that number looks pretty big. When people see a big number, then they won't ignore it. Yeah. So for that reason, yeah. Per billion hours, you do not use 1 hour per hour. Per hour, too small. Number of failures too small. But you increase the period to 1 billion hours. Huge period. Then that number will be big. That failure number would be big. So we go back to 1 million MTTF. Okay, 1 million MTTF. Yeah. If we use this one, you multiply 1 billion, you will get 1,000. Yeah. So then you get this failures in time, FIT, per billion hours this time, okay? Not per hour, per billion hour. You will get 1,000 failures per billion hours. That's a big number, 1,000 failures. Then nobody will ignore it, right? How can anyone ignore 1,000 failures? Nobody can ignore that. Yeah. So that's the purpose. Yeah. All right. So next, mean time to repair. After there is a failure, the service provider, they need to repair it, right? When you repair the problem, you need time, right? You need to spend some time. So then measure that. You'll get MTTR, mean time to repair. Okay? Yeah. So another important measure. Yeah. Then after that, yeah. So here, so let's look at this picture. Yeah. Failure occurs, right? Yeah. Then spend some repair time, right? So this is the repair time. Okay. After certain number of hours repair time, then resume of operations, start working. Yeah, so you get this MTTR, this part. Okay, then you start working. Yeah, so deliver the service, right? Long period of time. Then failure occurs another time, right? So this is MTTF. From this picture, you can see these concepts clearly. Okay, yeah. All right. Then another concept called mean time between failures. One failure, when you encounter the first failure, you record the time. The next time you get another failure, you record that time. You take the difference. Mean, you do this many times, taking the average mean time between failures. Yeah. So that's the MTBF. So you can see that period contains two parts, MTTR and MTTF. Yeah, between two failures. Yeah, so we get this formula. MTBF equals MTTF plus MTTR. Yeah. All right, so all these symbols, notations, yeah. All right. The next one, I like to use this picture to explain a little more about the breakdown of the time to recover the service. So when you have a failure, what the service provider should do to recover the service. From this picture, you can see a lot of things should be done to recover the service. Yeah. First, failure occurs. So then the customers, they should notify the service provider something is wrong. You need to send someone or a team to fix the problem. Right? So notification, that takes time, right? Yeah. Then a team, let's assume a team come and work on the problem, diagnosis. Well, you need to spend quite some time to do the diagnosis, right? Yeah, so next period. After they find the problem, they start to repair, right? To repair time. It takes certain number of hours to repair it. Okay? Yeah. All right. After repair step done, testing, you do not know if it works well or not, right? Next, testing. Then after testing, return to normal operating conditions. You need to spend some time to restart it, right? Return to normal condition, reset, restart, do some things to make it work in the normal situation, normal case, like that. Then that's the, the total amount of time used to fix the problem. All right, so then next, for non-redundant systems with repair, here, this word, non-redundant system. Many times the system is not redundant, so that means you do not have the backup part to make sure you can do the backup of things when something is wrong. So non-redundant, no redundancy. Okay, but no redundancy, the whole system, it's very easy to make the whole system break. So when that happens, When that happens, yeah. So then the cost is very high. Yeah. The cost is very high. Yeah. So we define a concept called the module availability as a percentage number, the ratio MTTF. You know the meaning of MTTF, right? Over MTTF plus MTTR. So that ratio, we define it as module availability, the percentage, module availability. Okay? Yeah. So we want this availability number as high as possible. Yeah. All right, so that's this part 3. Next one, we will, talk a little bit about redundant system a little bit. Yeah. So then we do a simple example. So we will complete this part. All right. Yeah.